just because I want to continue with this one, I'll make this one a two-part video. I talk about Murphy's laws. Those are the quantum gravities to load and unload in bays. Triage are what happens when that doesn't work right, or how you stop the bleeding. How do you pair a doctor with that system? What is the quantum mechanics of the answer? Now the hose is squirting all over the place, that it did go wrong. Well, it takes some basic physics. You take a clamp, you close it off, you know, that kind of thing. And the flaw behind this is in the universe. I like to look at that and when I'm talking about stuff like this and say, well, mathematically, A mechanics is the stone dock, but mathematically, it's also all these equations that go into it. When you look at that, they're lying to you. There's a flaw in all that mathematics that doesn't directly apply to the real numbers when you look at a company that doesn't have all of those. And their NP problem is very different than the one you would set up for a universal field theory, kind of the one I got here. Just saying, you know. But even that's not going to be correct. You wouldn't use all of these in this order. You wouldn't start somebody with the laws of motion for whatever they're doing. You're going to need to be, what is the most dominant feature here? Why do I start somebody with that idea? And even inside of that, there are multiple breakdowns of specific jobs. But basically, you're always training them to be a general. So, Socratean method is, again, a lot about psychology. You know, looking at this and being very philosophical about it. That's Socrates. You know, they have deeper meanings. They have, and see how these other things are always reverting back and forth one way or the other. General relativity, non-locality. Now, again, when I generalize a stone dock or a bay and want to hear, that's basically non-locality. The bays change. It looks a little different. But basically, it's the general drawing until I put in Jordan in there, until I put in a certain order of stone. You know, and even in that aspect, when you look at special relativity, when that order of stone changes in there, it changes it to general relativity because those numbers are still very general to what you're dealing with and what can, in the multiple options, happen into a place, or what that can possibly do. But specifically in this conversation, those are going to be the right answers for these X, Y, Z dimensions. So I actually use a lot of general relativity. I've studied this stuff. I've used the book. I've broken it down into all kinds of different special fields that I feel are a little bit better in terms of teaching what general relativity is by applying it simultaneously with special relativity. This is a lot of combinations of both in a proper order that I created, that I invented, and I broke down into a specific lecture for, because it works really well. And hopefully you guys are seeing it right now and would agree with me. And if you ever want some more conversation on this aspect, I'm more than happy. The laws of motion, which again, you look at this NP problem, we've already described. We've already talked about that. But specifically, like when you look at that saw and you fuck it up, it applied to physics. You know, when you first learn to fly, you can flap your wings and you might fly the first time, but either way, physics is going to be involved. What happened was something along the lines of a programming error or lack of understanding of physics. You know, look, when this hits this, it's going to go like this. When it's moving in this direction, it's going to stay in that direction. When that dude is fucking grinding, they're going to grind like that all the way through, generally. That can change because we don't apply directly to the laws of motion. A lot of special relativity goes into that, but the quantum nature of the universe, all this is preordained to a certain degree that you can prove. It was happening exactly when that phone call from your wife happened for exactly the reason it happened, although it's some car accident, because you can't really see all the dark matter calculations or whatever. And I knock on wood, I don't want anybody to the laws of thermodynamics, Albin-Nielsen-Heinrich's work, which there's a few of them. That's a very hard one to describe. I actually bring that up when I'm talking about the air turbulence equation, or what do they call it? Nova-Stroker's air turbulence equation, or flow or smoothness and existence turbulence equation. You kind of got to know those equations. You got to know what each symbol stands for. You got to know mathematics to understand that equation. But at the end of the day, you're just going to change out the letters. A is A mechanics, a stone dock. The symbol sum is equal to all these other half divisible this half E-shaped thing, T, time, over this half E-shaped thing, which is saying half the X is time, half the X is velocities and accelerations and everything else. And again, when you get into Nova-Stroker's equations, you're going to be getting into gradients and Lapicants. How much is it raising in velocity, positive accelerations, negative accelerations, because when this air molecule moves, when you take this idea of a stone dock being A mechanics, or the first letter in Albert Heinrich's works, the last, you take all of those equations, there's a few of them, and you line them up. They'll look really similar to an air turbulence equation, and how you position them is you're taking them and you're saying, well, this is very smooth, and thinking about how a universe works, and it exists because we can prove these numbers mathematically. Now that's done in algebraic elementary physics. Very incredible, but again is not really true. You can't really use those equations to anything on a stone saw or anything like that, or landscape and business models, but they definitely work. They have a very base law of motion to how to understand this, and even when I'm thinking about how to crack the universal field theory, I'm using that equation. Taken. How much time does it take to describe this? How fast will those terms jump? And when they reciprocate down to infinity and back down to this one thing being a zero state, that happens very fast. And you need to have information in there to slow it down, create a resistance of this hurricane moving and all that other stuff. So, Nova-Stroker's equations on air turbulence, smoothness and existence. How to describe, it's more than just watching the fucking Weather Channel and getting, oh, well, it's about this skew of the spectrum of maybe this other wind force or low pressure, high pressure, creating a certain degree. All those numbers go into, even there, still create a little bit of flaw. But I know about generally all the positions of those flaws, and I'll tell you about them on the Weather Channel. You could just say, how do you make this air turbulence equation simpler? Watch the fucking Weather Channel. No, it don't work that way mathematically. You gotta know your shit. Pay attention in class. Free radiant energy equations, which will go back to, see, I'm talking about that. That's what I'm talking about. Free radiant energies are psychology. Is Ohm's law on a saw. We could go to there. That's, if you studied that stuff, you could tap into that energy and go be a math teacher. Use that as your example of the problem. This is this many volts, this is this many resistors, transistors, in circuitry engineering. Well, just how you run around the shop as a photon, as an electron, is basically the same problem. I run into orders, which are the resistors. I run into the chisel first, which is a transistor for my torch hand. It gets weird. Planck scale, which is Planck spectrums, the fourth dimension in space-time, but you got to know those equations again and be able to take each individual and break it down into reality and be specific, generally specific. And what I mean by that is you have to generalize it, but every time you generalize it, you're being very specific to this company, this process that has a lot of different STEM testing, time systems to when you change the order. Growing plants, I use the lights. More so than just the color spectrum, but if you set up two different lights, that's a Planck scale. That's a STEM testing Planck scale. And special relativity, a special variation of that test to how many I'm doing, how many times it'll take, because I could set up 50 of them. But if I only had two, right there, those 3, 4 equations, if you look at the first symbols of the first equation, they should lay down in a proper matrix to a CZ function x, y, ax, by, cz, because it's extending the laws of motion the way it behaves. The art of war, and I use the example of way a resistance, but if you actually study the art of war, I would recommend writing it word for word, because it's going to change how you can read it. I've done it, but when you write it word for word, there's an idea of calligraphy. There's an idea of education, there's an idea of mathematics, there's an idea of psychology that goes into all of those features and weighing amechanical resistances. Why do I need to know the farmer? Why do I need to know all the material of that other place before I go to war with it? Because if I didn't, one, I don't know if the people would really want me to lead it. It's just all kinds of crazy, which that stuff will help you do. I teach it in my model. Army survival, specifically Army psychology within Army survival. You don't always need the rabbit trap, but we'll go back to Hunter's Prize. I can parallel those ideas because this is my course lecture to explain that. You can get this from the Stone Diet. You can get that from your psychology of surviving. Look, you do this not because it's a thriving aspect, but that's in the flaw model. It's going to get you eventually. Time just ticks that way. But you know, how do you make it easier on yourself? You're picking up that rock, you're changing it into an arrowhead instead of just throwing it at the rabbit. You're gonna tie it to a stick and make something to make your life a little fucking easier, which is a lot of the model what that's about. Not just going in there for the crown. You know, you're here before your own reasons. It's not just containing the bullet in the barrel. When you think about all the troops and everything like that, it's a lot of these equations. This is this little equation shooting down this box and knowing exactly where it's positioned, how fast it's going when it's going in that barrier because of a different dimensional axis, and how it will continue in that trajectory, and based in those mathematics and the laws of motion, and how that applies in other variations of the equation. I need stuff in front of me. It's very hard mathematically to describe some of this. Military Joint Chief Dictionary of Terms. Basically what this is in a Universal Field Theory Bank of Terms, NP problem is a Military Joint Chief of Staff Dictionary of Terms. I'm not particular. I don't need aircraft carrier. I don't need nukes. We can get there from here. General relativity, blanks, you know, some of the stuff you'll see. Air turbulence equations when you're dealing with nuclear fallout. If you don't know that stuff and you just let it fly, obviously you're not military. It's just the way it is. They practice every variation, permutation of calculations that come off in the book. Math is like a fist fight. Math is like ruling a nation. Math is, if you understand it like that, it's a fast way of learning how to do it. And it can help you make calculations of great matters a little simpler than just trial and error. But at the end of the day, a lot of this mathematically was just trial and error. It's weird. Base psychology, and that's BACE. When we're talking about being a mechanical causal energies in psychology, you don't start with the math equation because Army survival and A mechanics is a model of psychology. It's the A mechanical model. Beyond that, you can get into a lot of different types, and we're talking about a bunch. Bipolar, kids, family, work, you know, BACE. Talking about the B models before we talk about the A mechanics that go into each of those B models causally, and how we're going to specifically lay that out to somebody's or the general topics criteria. Base trigonometry, A, B, C. When I'm working a saw, we're talking about A mechanics to the B models in this right angle that's going to make everything right and tight causally. And that causal line depends on different times and masses that would make a specifically sized line. It's very difficult, but remember, we've already covered a lot of this, so it just reinforces it, reciprocating under different terms that never have the same definition. Even when I look at the same thing and I change a person's name into that psychology, it's going to change the direct physics into what criteria I specifically laid out, or monetary system, when you want to put a number to some of that stuff. It changes. Base physics. Again, physics is a lot of elementary physics equations, which can really fuck people up. But when you talk about base psychology, BACE, we're talking about in this stone dock. We're talking about in this place. And it's not necessarily that any one of those three, well, I'll get into basic economics and basic algebra here in a minute, but it's not that any one of those physics aren't going to help you do this. How did I want to say that? Very specifically to somebody's need there. And you can tap into anybody's numbers or weights or time systems, analyzations, and what have you from any one of those places, which will give you the skills to learn how to do the more advanced mathematical stuff that comes with that. Economics, algebra. Catch you on the next one.